Alright, problem number 19. Cherry Hill math teachers just discovered a new function, z of x equals YOLO x. Okay, so this is a function that we've never seen before. We don't know what it is. It's strange to us, but they're asking us to take this function z of x and perform some transformations on it. And so here's the big idea. Even when you come across functions like YOLO x and you've never heard of them before, you can still put the a, b, c, and d in their appropriate spots and do the transformation. So if we're saying vertically stretched by a factor of 2, that's usually something that is multiplied outside of the function. So we're going to say 2 times the function, okay? And I'm just going to leave it open right now because it says translated to the left by 2. So translations to the left by 2 would look like x plus 2, okay? Up by 5 would be plus 5 on the outside, and then reflecting over the x-axis would be meaning that the a value has to be a negative number. So I could make it this new function, and let's call it like, I don't know, y of x, okay? So if I have this new function, it didn't matter that my original parent function was something that we've never seen before. We don't know what the graph looks like. If they describe transformations on a parent function, this even if it's new to us, all of the idea of transformations will still apply. C will move left and right. A and B will move, D will move up and down. A value will do reflections and vertical stretches, right? So even if it's a strange function, you can still perform those functions like you normally would, okay? So problem number 20, it says you find that an ant colony's population doubles every 4 hours, and its population at time t equals 0 is 500 ants. And it's asking us to write a function that could represent the population after t hours. So we're going to say p of t, okay, equals, and then we're going to, in this case, because they're talking about doubling, so we're doing times 2 times 2 times 2. Whenever we repeatedly multiply, it's really an exponential function. So if you remember from exponential functions, we said generally they look like a times b to the x, where a is the start value, okay? B is your multiply value, okay? We call it, I'll even use the correct terminology, we call it the growth factor. Okay? It is the number that we are repeatedly multiplying by, but it's called the growth factor. Okay? And then usually x represents an amount of time, but it's really the number of times that we are doubling in this case, or however we're doing the increase, but in this case doubling. So our starting value, they tell us, at time t equals 0 is 500 ants. Okay? So I'm going to replace a with 500. Okay, my b value in this case is 2 because I see the word doubling, so I'm going to say 2. Be careful, okay? I know we've done a lot of problems that had percents in them, and we did 1 plus the value, like 1 plus 4% would be 1 plus 0.04. This is not a percent problem. We're not increasing by 2% or something like that. We are doubling, so we're just going to say, you know what, not 1 plus. Those are for problems with percents. We're just going to say doubling times 2, okay? So we're going to say 2 to the x, okay? So this is my function that, we'll use the value that they use, which is not x, they use t. So I'm going to get rid of this and replace it with its correct value, because we're doing p of t, we're going to place that with a t, right? And so this we could use this now to do a prediction for any number of hours starting at time t equals 0. Letter B, it says create a graph using a table of values that represents the population for the first 12 hours. Okay, so they're just giving us a blank grid. It says identify any x or y intercepts, explain what they mean, how many ants will there be after 30 hours. Okay, so let's start off with letter B. It says create a graph using a table of values. So I'm going to plug in, okay, 0, 1, 2, and 3. Right, and here's where you got to be careful. This 0, okay, is my time, and so what that's going to represent for us is time 0, which is easy, okay? This 1 represents a 1 here, and that is a change of 4 hours. So this 1 actually represents my first change of 4 hours. This represents after 8 hours. This represents after 12 hours. So you have to be careful. This doubling is not happening every hour. It is happening every 4 hours. So every single time I increase t by 1, I'm increasing the number of hours by 4. Right? So just be careful that your intervals match what they're supposed to match. So let me move down. We're going to label our graph, okay? And I see it in this case 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Looks like we have about 20 dashes across. I'm only going to use these 4, and that's because it's only asking us to go up to the first 12 hours. So we just need to make sure that however we space it out, we're doing so appropriately. So I'm going to say in this case, let's just give 3 spaces and call this a 1. Let's do another 3 spaces and call this 2. Okay. Let's do another 3 spaces, call this 3. Right? And then obviously at the beginning I have 0. So this represents hours. And I probably could have spaced this out more, but this is fine. Okay. And then I can go up. I'm not going to label this one yet because I don't know what my y values are. So let's figure out what the y values are. If I plug in 0 here, it says 2 to the 0, which is 1. 1 times 500 is 500. Okay. When I plug in a 1, this now says 2 to the 1, which is 2. 2 times 5,000, or 2 times 500 is 1,000. Okay. When I plug in a 2, this says 2 squared. Well, 2 squared is 4. 4 times 500 is 2,000. Okay. And when I plug in a 3, this says 2 to the 3rd, which is 8. 8 times 500 is 4,000. Okay, so it looks like my y-axis needs to go from as low as 0 or as low as 500 up to 4,000. So again, I'm assuming I have about 20 spaces to work with here. So I'm going to just count by like 4s here. So I'm going to say that this again represents 0. Okay, we'll say that this represents 1,000. Okay, 1, 2, 3, 4, another 1,000. Okay. 1, 2, 3, 4, another 1,000. Okay, 1, 2, 3, 4, another 1,000. Okay, so something. Oh, this is 4,000, and I don't need to go higher than 4,000 because my highest y value is 4,000. So I'm going to graph these points down. 0, 500 is this point. 1, 1,000. 2, 2,000, and 3, 4,000, which would be about right here. And my graph's a little bit inaccurate. That's just because I'm trying to get through this quickly. So it looks like it's going to go something like that. Okay. So that's letter B. It says create a graph using a table of values for the first 12 hours. Well, this x value of 3 represents hour 12, okay, which it looks like my line is off a little bit. That dot should be right there. But you get the idea. Okay. Let me fix that, okay, since I see it. Okay. So we'll say this represents my graph. Okay. So something along those lines. I think my 2's off as well, but that's okay. You get the idea. Okay. Now let's answer letter C. It says, identify any x and y intercepts and explain what they mean in the context of the ant colony. Well, in this case, if we keep extending this, we don't have a y-intercept, or I'm sorry, an x-intercept. This is my x-axis, and the graph stops right here at time 0. It never crosses the x-axis. So I'm just going to write no x-intercepts. And that's fine. We shouldn't really have any x-intercepts. Okay? And then y, in this case, is 500. So I'm going to say my y-intercept is the point 0, 500. And this represents the starting population at time 0. So I'll just write at t equals 0. Okay? So I'm going to say starting population at t equals 0. At time 0, there were 500 ants in the colony, and we went with that. Okay? Letter D, it says, how many ants will there be after 30 hours? Okay, so again, we have this idea that I'm going to use my function, p of x equals 500 times 2 to the t. Okay? Well, this was a t. Okay? And I need to plug in a value here that represents 30 hours, and I'm increasing by 4s. So again, let's be careful. So we know that it's going to go times 0, then time 1, 2, 3, 4, 5. Let's see what this does. Okay, so I'm going to say each of these represents a 4-hour interval of time. So this is obviously time 0. This is 4 hours, 8 hours, 12, 16, 20. So I'm only at hour 20. I need to get to hour 30, so I'm going to keep going. 6, 7, 8. Okay, so I'm going to say this is time 24. This is time 28. This is time 32. Okay, so now I'm saying when my t-value is 8, I'm at 32 hours. When my t-value is 7, I'm at 28 hours. I don't need either of those. I need something right in between those. So I need, it looks like 7.5 as a t-value, and that would put me exactly halfway between 28 and 32. Okay, so you have to be careful with these inputs. Okay, we're going to say in this case p of 7.5 equals 500 times 2 to the 7.5, right? So again, just be very, very careful with that. I'm going to bring up my calculator again so that we can see what this comes out to be. And so I'm going to say 500 times 2 to the 7.5. And so after 30 hours, we're expecting there to be somewhere about 90,510 ants in the colony. So I'm going to say P of 7.5, about how many ants will be in the colony after 30 hours. We're saying about 90,510 ants. Okay. So again, the hardest part about this is actually saying T represents 4-hour intervals, so here are the 4-hour intervals, and ours happens to be somewhere in between two whole numbers, and so you have to be careful about how you do that. So you could have easily, just to get this 7.5 done, 30 divided by 4, and that would have gotten you the 7.5, but I wanted to show you using the table how that came to be. Okay, so just be careful with that. Problem number 21, it says the graph below, or off to the right, represents the stock value in dollars over a 12-hour period. Explain the meaning of the asymptote. Okay, and so my picture's a little bit small. Let me see if I can make this a little bit bigger so I can see it. Okay, which I really can't. Okay, so I believe that that's 40. Yeah, that looks like 40 to me. Okay, so we're going to go with that. We're going to say that the asymptote in this case says that the stock price, okay, will not go below $40, okay? And that's what an asymptote is. It's a value that it will not go below or above, depending on which way we're going. But since we're traveling downhill, it's approaching 40 from the top, so it will not go below. It will not, let me write words correctly, it will not go, wow, I can't write today. All right, let's fix this. It will not go below $40, okay? Writing is my worst thing, right? So we're going to say that the stock price, it starts off really high. As the number of hours go along, it flattens out right above $40, and it will not go below $40, and that's what an asymptote in this case means, okay? Problem number 22. Okay, so we're being given a set that says 10, 12, 13, 15, right? This really big set, a list of numbers, right? And they're saying event A is a number that is a multiple of 4 given this set. Event B is a multiple of 5. Event C is an odd number. So let's take this original set and let's just write off to the side here what our new ones are going to look like. Okay, so I'm going to say event A, if it's saying a multiple of 4, we'd say, well, that's 4 times 3, so 12. Okay, 16, 20, and that looks like it, right? No other multiples of 4. Okay, multiples of 5, okay, it would be 10, 15, 20, 25, and 30, okay? And C is odd numbers, so we're going to say 13, 15, 23, 25, and that would be it. Okay, and so letter A says list the outcomes of A union B intersected with C. So let's first do A union B. A union B is going to be putting together these two lists, but we're not going to repeat any number that shows up in both lists. So I'm going to say A union B in this case is 10, 12, 15, 16, 20, but I'm not going to write both of them. I'm just going to write one of them, 25, and 30. So that's A union B. And then I need to intersect this list with C. And I'm looking, so intersection means let's take a look at this list and let's take a look at C and let's only write the values that show up in both lists. So I'm seeing in both lists the number 15 and the number 25 showing up in both lists. So I'm going to say the answer to their question, A union B intersects C, is 15 and 25. And that's it. Okay? This is your final answer for A union B intersection C. And so letter B is doing the same thing, and they're saying, what is A union C? So let's put together A and C. So that looks like it's going to be 12, 13, 15, 16, 20, 23, and 25. And then I'm going to intersect this with B, which means now I'm going to look at this new list, and I'm going to look at B, and I'm going to write anything that shows up on both lists, which in this case would be just anything on this list that also happens to be a multiple of 5. So that would be the 15, the 20, and the 25. Okay, so I would say this list right here is A union C intersected with B. Okay, so that's just using your set notation in order to do some problems. All right, problem number 23. On Tuesday, Chipotle had 280 customers, and the sales data is reported below, so they broke it up by people that bought a burrito and did not buy a burrito, and also into men and women. So if I'm just gonna complete this table first by adding across to get a total people that bought a burrito, which that looks like 112 people bought a burrito. Okay, did not buy a burrito. It looks like 168. Okay, and when I add down these columns, I better get 280 because that's what they told us was the total, and I do. And then I'm also going to complete the total for men and for women. So if I add down the men column, it looks like I get 84. And when I add down the women column, it looks like I get 196. And again, I'm just going to check that when I add across this, I get 280, and I do, so I'm good. So now it says, what is the probability that a customer bought a burrito? Well, I had 280 total people, so that's the denominator. And bought a burrito, we did the total and said 112, right? And so I'm just going to leave my answer like that. You can reduce or turn it into a percentage, but any equivalent form should be fine. So I'm going to say 112 out of 280 is the probability that somebody bought a burrito. Letter B says, what is the probability that a customer is a woman who bought a burrito? Okay, so we got to be a little bit more careful. So I'm going to rewrite this as bought a burrito, okay, given, okay, which we use that bar for given, that they are a woman. Okay, so I'm going to go to this one and say, okay, so go to the woman category. I know it was a woman, and there were 196 women, so that is my denominator. Okay, and I'm only going to list the women who bought a burrito, and that would be 49. Okay, so I'm going to say, given that I know that the person was a woman, what is the probability that they bought a burrito? Well, that is only 49 out of the 196 women. So this is a problem where our denominator got restricted because we were given information that the person that bought the burrito was in the woman column. Okay. Letter C, what is the probability that a customer is a man or bought a burrito? Okay, so when we're talking about these or problems, these are problems where we are going to look at all of the men, right? So let's do that. The probability that somebody is a man is 84. Okay. Oop, I'm starting to get some feedback here. 84 out of 280. Okay. Bought a burrito would be, again, let's look at the burrito column. That's 112 people. Okay. Hopefully my pen will last. I might have to end the video here and end it in another one. Okay. Looks like my pen's being a little strange. Okay, 112 out of 280. Okay, but here's where I got to be careful. So let's recap that. All the men out of 280, all of the people that bought a burrito out of 280, but there was a group of men, which when we look at our column, there were 63 men that bought a burrito. So I counted those 63 men as a part of men, but then I also counted those 63 men again when I was talking about people that bought a burrito. So now I need to subtract off those 63 because I accidentally double counted them, and I don't want to do that. And so we're going to say 84 plus 112 minus 63 would be the same as 112 112 plus 21, right, which would be 132 out of 280 people. Okay, so I would say because I double counted those 63 people in both of these groups, okay, I'm going to say let me subtract off just the 63 people that are in both lists, meaning that they are both a man and bought a burrito at the same time. So, or probabilities. Last one, what is the probability that a customer is a man given that the customer bought a burrito? So again, the given is going to restrict my denominator. So given that they bought a burrito means that my denominator is only going to be the number of people that bought a burrito. So I'm going to say in this case 112. Okay, so I'm going to say 112 becomes my denominator, which you cannot see because it's off the bottom. So let me move down. Right, so 112 people bought a burrito. So now I'm going to go back up to the top. It says given that the person should be only a man. So that would be 63, okay, out of the 112. Right, so again, this is a given problem. Once we get new information, our denominator is restricted. 63 out of 112 is the probability. So let's finish up. Looks like my pen's working again. Okay, problem number 24. Given each function, predict the number of dollars in year 2018. So in letter A, they're just giving us the function, and they specify that X represents the years since 2010, and Y represents the dollars. So if X represents the year since 2010, it's been 8 years since 2010 in the year 2018. So I'm going to say 20,000 times 1.02 to the 8th power. So again, we're using 8 because we're doing 8 years since 2010. Okay, so I'll let you type this in your calculator and get the actual value. Okay, letter B, we need to kind of look at a table and say, well, what's the pattern going on? They want us to go to the year 2018. I'm stopping at the year 2014. So my job is really to look at the right-hand side and say, as I increase the years by 1, what pattern is involved to increase the dollars? Well, and it looks like in this case, we're just saying plus 2,000 every single time, right? Every single next row is 2,000 more than the last. Okay, so I'm just going to keep doing that until I get to 2018. So 2015 would be $3,000. 2016 would be $3,200. 2017 would be $3,400, which means 2018 would be $36,000. Okay, so if I keep just adding 2,000 to this list 4 more times, I will get myself up to $36,000 in that year. So just look for the pattern on the table and continue it down, or if they ask for something earlier than 2010, we could also continue it up. Okay, problem letter C is just like problem letter A. They're saying years since 2010, so I'm going to replace the 120 or the X next to the 120 with an 8, because that's been 8 years since 2010, plus 20,000, right? And again, you'll get your X value. So even though that these functions look different, this is an exponential function, and this one down here is a linear function, we're still going to plug in 8 because they tell us that that represents the year since 2010, and that's 8 would represent the year 2018. Okay, so here are your kind of miscellaneous topics to wrap up. Problem number 25 is asking us to multiply together two radical expressions. So this is just FOIL. So I'm going to say 12. Okay, I'm going to multiply these. I can't multiply together a whole number and a radical, right? And so I'm going to say that this is really 3 times negative, or we'll just say plus 3 times the square root of negative 1. I'm going to multiply these ones together. Same problem. I'm going to say plus 4 times the square root of negative 4. And when I multiply these ones together, the square root times the square root, I can just multiply what's underneath the square roots. So this is just going to come out to be the square root of positive 4, because negative 4 times negative 1 is 4. Okay, so now here's where we're kind of starting to run into some stuff. We have to deal with these negatives inside of the radicals, which are I problems, right? So if I say the square root of negative 1 is I, I'm going to say this is really 12 plus 3I. Okay, the second one, if I break up, I'm going to do it up here, the square root of negative 4 into the square root of negative 1 and the square root of positive 4, well, this is 2, and this is I, and then I had another 4 sitting out front, right, this 4 here. So this really says 4 times 2 is 8I, right? And then I can simplify this one as well and call this one just 2, right? The square root of 4 is 2. So now I can do some more combining, because I can say 12 plus 2, well, that's 14. 3I plus 8I is 11I, right? So this is using what we know about I to take this FOILed problem and turn it into a simple form. Okay, problem number 26 and 27, I'm only going to do number 26 because they're very similar in nature. Okay, whenever we're trying to simplify higher order or higher index radicals, we're just going to use the powers, in this case the cubes. In this case I'd use the fifth powers. So I'm going to say the cube, the perfect cube in 48, well, let's see, I can do 2 cubed, which is 8. I can do 3 cubed, which is 27. I can do 4 cubed, which is already 64. That's too big. So it looks like 8 is the largest perfect cube in 48. So I'm going to break up 48 into the cube root of 48. I'm sorry, the cube root of 8. Right? Well, and my other factor would be a 6. Okay? And then when I'm dealing with exponents, I'm going to deal with only multiples of 3. Right? Because I can take each multiple of 3 and divide it by the index in order to simplify the exponent. So in this case, the x cubed is fine. I'm going to say this is just the cube root of x cubed, because 3 is a multiple of 3. But the y to the fifth, I'm going to break up a little bit more, and I'm going to say this is y to the third and the cube root of y squared. Right? And that's because I can at least simplify this piece of y to the fifth. So let's now simplify. The cube root of 8 is 2. The cube root of x cubed, I divide this 3 by the index, and I'd say that's x to the first. I can do the same thing with this y to the first. And then these two pieces right here I could not simplify because they are not perfect cubes. So I'm going to put those back together, 6y squared, underneath the radical. Okay, so 27 works the same, except you're going to use multiples of 5 for the index, and you're going to use only perfect fifth powers when you're breaking up 64. Okay. So, problem number 28 says, find all solutions, 3x squared minus 2x minus 4. That's just solving a quadratic. Okay, we're going to set it equal to 0. Okay, so we're going to say 0 equals 3x squared minus 2x minus 4. Okay, so we're going to start off by looking at this and saying, can I AC factor this? So can I find numbers that multiply to negative 12, that add up to negative 2? And if I'm thinking about my list of factors, 4 and 3 don't work, 6 and 2 don't work. Right, so it doesn't look like I can factor these because I cannot find factors of negative 12 that add up to negative 2. So what that means is I need to use the quadratic formula. So I'm going to say 2 plus or minus the square root of negative 2 squared is 4 minus 4ac, okay, all over 2a, which would be 2 times 3. So I'm just going to put a 6. Okay, so let's simplify into the radical. This says, sorry, this is a really bad looking 4. Okay, so this says now if I did negative 4 times 3 times negative 4, I get negative 16 times 3, which is positive 48. So if I simplify just under the radical, it says 2 plus or minus the square root of 4 minus 48 all over 6. Well, 4 minus 48 is something that I can simplify more. 4 minus 48 looks like negative 44. So I'm going to turn this into 2 plus or minus the square root of negative 44 over 6. Okay, and now I'm just going to use I again. So this is something where this has a perfect square of 4 in it. So I'm going to say this is equal to 2 plus or minus 2I root 11 over 6. Okay, and so if you're unsure about where I got this from, I'll just do it right up here. Okay, the negative 44 is the square root of 4 times the square root of 11 times the square root of negative 1. Well, the square root of 4 is 2. The square root of negative 1 is I, and then the square root of 11 I just kind of brought down. Okay, so we're basically done. The only thing I have left to do is I'm noticing that all of the numbers outside of the radical, the 2 and the 2 and the 6, they all have a 2 in them. So I'm going to simplify this a little bit more, and I'm going to say 1 plus or minus I root 11 all over 3. This would be my most exact answer in simplest radical form, okay, of my number 28 f of x function. Okay, so I'm going to skip 29. I'm going to save that till the end. We'll do that problem, but I want to just jump into number 30 because that's the last one that involves me writing, and I want to make sure that my tablet doesn't run out of battery. Okay, so problem number 30. I'm going to erase this answer so we can see all of it. Okay, it says, suppose you won $3,000 in a contest. Your mom's making you deposit it in an account with 5% annual interest compounded continuously or monthly for 3 years. Which would you prefer? So, suppose you, the word continuously, right away, I'm thinking P-E-R-T. Okay, so let's just solve this one. I'm going to say A equals P-E-R-T. Okay, so I'm going to say P in this case is my $3,000. Okay, E is E. That's our 2.71, 2.72 number. My rate in this case is 0.05, so 5% in decimal form. Okay, and this says 3 years. Okay, so I'm going to say times 3. Okay, if I was doing the other option, monthly is going to be that other function that we learned about, which is P times 1 plus R over N to the NT. Okay, so in this case, because I'm not continuously compounding, I'm monthly compounding, I'm going to use this function. And so for this one, I'm still going to use 3,000 for P. I'm still going to use 0.05 for R. The only new part of this one is N, and N in this case represents the number of compounds per year, which monthly tells us 12. So I'm going to say this is my inside of the function, and it's going to become in the top 12 times 3. Okay, so I'm going to bring up my calculator again so we can check this problem out. Okay, and this says for the PERT 3,000. Okay, and then it's E. Where's my E? To the 0.05 times 3. Okay, and so this looks like the answer is 3485. We'll just say 3485. Okay, so that would be my dollar value if I compounded continuously. Okay, and so for the other one, I'm going to do the same thing. 3,000 times 1 plus 0.05 divided by 12. Okay, I'm going to close that, and then I'm going to raise that to the 12 times 3. I'm just going to type in 36 because we can do that. Okay, so this one comes out to be 3484. So it looks like they're really close to each other, but it looks like continuous is going to give us about an extra dollar worth of interest, okay, versus the compounding monthly. So slight difference, but hey, I'll take the extra dollar. All right, so let's talk about problem number 29. This one, it says use a graphing calculator to find the intersection. So I'm actually going to make my graphing calculator a little bit larger so that you can see it. So let me bring up my thing. Let me move this over. Okay, and make it a little bit bigger for you. Okay, and so what we're going to do is we are going to type each of these functions into the y equals button. So on my calculator, okay, I'm going to go up to y equals. okay, which is this button right here. And I have a bunch of entries, and I'm going to type each of these in. So I'm going to say 3 to the, and then it says x minus 1. So my x button is right here next to the green alpha, x minus 1. Okay, and then I'm going to end my exponent by hitting the right arrow, and then I'm going to say minus 4. Okay, and I'm going to hit graph, and just make sure that that's going to graph. Okay, and I can see there's my function. That's 3 to the x minus 1 minus 4, and it's going to jump up. That looks like an exponential. That's good. That's what we're looking for. Okay, and it wants us to compare that with, so I'm going to go back to my y equals, move down to the next y2, and it says 5 halves. So I'm going to open up a parentheses, 5 divided by 2, x minus 3. Okay, so I just typed in the linear function, and because I had a fraction, I put the fraction in parentheses. So I'm going to graph, and so here comes my 5 to the x minus 5 halves x minus 3. And it says, use the graphing calculator to find the intersection. So here are your intersection points. To do that, we're going to use this calc function right above trace. So if I hit second trace, if you notice, one of my choices, number 5 here, is intersect. So I'm going to hit intersect, hit the number 5. Okay, and it says, what is the first curve? So I'm going to say in this case that the first curve, if you notice, when I'm hitting left and right, I'm on the exponential. So I'm going to hit enter and say my first curve is the exponential. And it says, what is the second curve? And so if you notice, when I hit the up and down arrows, it's switching between the functions. So I'm going to move over so you can see my cursor. So you can see right now my cursor is moving up the line, which means I'm on the line. So I'm going to hit enter there. And it says, do you want to guess? I'm going to say, no, I don't want to guess. Okay? And so here's what it's doing. It's calculating, and if you notice, it's blinking right now on this point right here. So I would say 0.304, comma, negative 3.7. That is a point of intersection. So you can write that down. That is one of the answers that the calculator is telling us is an intersection between these 2 points. Okay? So we're going to do this again. Okay? And because we have another intersection point right up here, and so I need to know what that one is as well. So I'm going to go back to calc. Okay? And I'm going to hit number 5. Right, and it says, what is the first curve? So when I do this, I'm just going to move along the function closer to that one. So I'm going to just hit the right arrow. I'm just hitting the right arrow. Oop, I went too far. Okay, and I'm going to say, my blinking cursor is right now on the exponential curve, and I'm going to hit enter. Okay, and now it says, what's the second curve? Okay, and I'm going to do the same thing. I'm making sure that it says it up here as well. Y equals 5 halves x minus 3, so I know I'm on that one. Okay, and then I'm going to hit, do you want to guess? My cursor's right around that blink, but I'm going to leave it alone. Okay. And now it's blinking on the top one, so I can say the other point of intersection, it looks like, is 2.92, comma, 4.32. So that's just using the graphing calculator, typing in both functions into y equals, and then asking the calculator to find the intersection of those two functions.